Just like in many cities around the world, public transport in Singapore is used by millions of people every day. However, an increasing urban population has led to various operational problems, typically emerging during the peak hours and affecting service quality. Overcrowded vehicles, slow services and long waiting times make public transport unpopular with commuters. Today, such operational problems are addressed by adapting the system based on expert knowledge. But a new solution might be close at hand. Like many other cities, Singapore has adopted a smart card-based fare collection system. Mountains of travel data are automatically generated as commuters board and alight trains and buses on a daily basis. The challenge is to turn this stream of big data into smart data that helps to plan for a better public transport system. Dr. Alex Erat, a transport researcher with the Future City Laboratory, explains.
Vehicle positioning systems are already widely used to make short-term predictions. Signboards at bus stops, for example, indicate customers at what time the next bus will arrive. Automatic fare collection data, on the other hand, is mostly used for ridership analysis. This, for example, allows to identify which bus lines are already running at capacity limit. Now, a new simulation system that can integrate and learn from both data sources at the same time would help us to plan and operate public transport systems in a new manner. Such a system could anticipate how travelers would react if a new line was introduced and predict its impact with regards to dynamic phenomena such as bus bunching, vehicle overcrowding and congestion.
The Mobility and Transport Planning Research Group at the Future Cities Laboratory is working on a way to fuel cutting-edge transport simulation software with new data sources and provide tools to help decision makers design more effective transportation systems. They adapted the open-source transport simulation framework MatSim to run on smart card data. Sergio Ordonez from the Future Cities Laboratory explains.
The system exploits the hidden information contained in the smart card data in order to extract the behavioral parameters of public transport users. It then uses this information to predict how changes in the public transport system might influence the customer behavior. It does so by simulating in a highly detailed agent-based platform that captures the movement of all individuals and vehicles in a city. This software can predict dynamic phenomena even before any of these changes are implemented. In this way, local authorities and public transport operators can evaluate their plans and their designs and develop the system that meet their goals.
Let us look at a typical test case where we have a very long bus line that covers more than 90 stops along its route. This bus line shows that extensive bus bunching occurs. Especially in the second part of the service route, reliability becomes more affected by traffic conditions and the boarding and alighting of passengers along the way. As a possible solution to the problem, we can split the line in two at a position which minimizes the need for extra transfers and then evaluate the service performance. As expected, the line split has removed most of the bus bunching cases and commuters benefit from shorter waiting times and less crowded buses. We can now evaluate how passengers will be affected by comparing travel times and the number of transfers made before and after the change. We can also see where passengers might switch from using this line or how the improved reliability might attract passengers from other public transport services. In fact, the system can simulate even more complicated scenarios, such as predicting ridership of new lines or assessing the impact of a city-wide network redesign.